Good afternoon. Welcome to the 2024 Rollout. My name's Dave. I'm going to be going through 6 of my top features for 2024. So we'll begin with the G-View cube, new on-screen gnomon. When you open Mastercam for the first time, you're going to see this G-View cube that's now in 2024. And I'm just going to show you that in Mastercam. So in this file here, we've got the G-View cube comes on automatically. So with this G-View cube, you can actually go from different views on it, and you can actually use the cube itself to rotate the views wherever you need. So if you want a top view, you can click on top. If you want a 45 on that, you can.
Hey, Dave,
Click,
I'm not
yes.
sure we can see your screen. I don't know, Lee, can you see his screen? I can't. Oh, there we go. Now I can see it.
Yes, I do see the screen, but the operations manager, if you maybe just want to minimize that over to the right or over to the left a little bit, it's quite big.
Sorry to
Okay.
interrupt.
Yeah, perfect. Slide that over.
Okay,
Excellent.
there you go. So with this G-View cube, you can, like I said, you can do different views and stuff like that. And then if you hover above each of the options here, you've got an option to pan up and down or left and right. And then again, if you hover above it, you'll get the option. You can click to pan or alt click, and it'll rotate it and then rotate it the other way. And then same on the panning up and down, you can rotate it towards you and then away from you kind of thing. So if we go to the left view and I do a click on this one here, it'll flip the part 180. And then again, you can get all the commands up on the screen just by hovering above it, and you'll get a shift click and you can rotate the part 90 now. If you do a shift alt click, it'll rotate it 90 the other way. If you do a control click, it rotates it clockwise. And then if you do a control alt click, it'll rotate it counterclockwise. Just so you know, you can shut the cube off if you don't like it or it's bothering you. You can still do your gnomons from that and create a dynamic plane. You can just pull that away. It's still able to do that. Or you can use the option. If you do a right mouse button click, you can create a dynamic plane, which is the same thing. And we've got an option here to show relative to the WCS. If we go into the settings, the graphics cube settings are on the left. So with the rotations, you can set an increment for that. So if you wanted to do 5 degrees, you could set 5 degrees here. You can change the cube's text size itself. You can also change the cube size itself and the cube opacity. The one thing you could do with this cube is you could set a view on it, and you can come to your planes and you can grab that same view just from G-View and create a view from that and use that for machining. So it is useful for different things. And like I say, you can actually drag this cube around to sort of see the part kind of thing and click on any of those faces to be able to get that to come up. So that's pretty much the G-View cube. And like I say, if you want to see the actual options for it, you can just hover above each of the, and a right mouse button click will get you into the options for it. So that's pretty much the G-View cube for basic overview. So we'll go on now. So the next thing I want to show is the graphics planes with hole making toolpaths. So they've added in this graphic planes now. So when you do a hole, any of the hole toolpaths will show up these graphic planes. So as it shows here, it'll put a clearance, retract, the top of stock, and a depth, and even does a tip comp. And you can turn those on and off as you need them kind of thing, or if you don't like them. So I'll go ahead and I'll show you that now. Let me load that file in. So now in this one here, if I do a drill toolpath, we'll be able to see all those graphic planes show up. So if I zoom in and I grab those holes, and I go to my linking parameters, first you can turn the graphics on and off by turning on and off the planes button here. So we can turn those on and off that way. If I turn on my clearance, you can see what's happening on the screen. So, and it gives you a graphical representation of what's actually going on. And if we change those, it'll update on the screen automatically for you. If I put on tip comp, you can see the tip comp coming up at the bottom there. I can also drag these if I want to on the screen to whatever number, and then it'll automatically update inside the toolpath parameters itself. If you wanted to move that up and have a regular number, like a 2-inch, you can actually type it in and off the keyboard while that ruler's on the screen. So you can have any number you want. So 2-inch. It's just a graphic visualization of what's going to happen with the tool. But the nice thing is you can pull this off to the side, the toolpath box itself, and you can look at the graphics on the screen. The nice thing about this is you can do all your depths and everything else on the screen, and you can actually check it before you actually make the toolpath and see exactly what you're going to get before you click out, kind of thing. That's available on all the toolpaths too. So you can apply that and it'll apply it there, and you can see what's going to happen in the toolpath. So you can, and again, you can turn those on and off if they bother you. So that would be the graphical plane for 2024. So moving on. So next we're going to go into dynamic trim. So in Mastercam 2024, they've basically taken all the trims and put it in. Sorry?
Yeah, sorry to interrupt. There's one quick question here.
Yep.
It says, is using the drill height plane tool per instance or for all holes in the op?
No, that would be all holes in that operation.
It's as you selected, because you had selected all of those holes.
Yeah, so that'll apply. You could apply it to one hole itself if you wanted to grab just the one hole, and you can apply it to that one hole, and you'll get the linking. So if there was one that was deeper or lower, you could do it that way, and you can, like I say, you can grab those on the screen and drag them.
Yeah. Okay. I think that answers that question. Thank you.
Okay.
Yeah, and just a reminder to everybody, if you do have any questions as we go, if it's pertinent to what we're showing, we'll address it at the time. But of course, we'll have a Q&A at the end. But feel free to type in any questions as we go in that option in your widget. Thanks, Dave.
Yeah, no problem. So for dynamic trim, they've basically taken all the areas of trimming and put it under one trim area now called dynamic trim. And it brings everything back into one nice package kind of thing. So when you do this, you have access to all the trim, 1, 2, 3, divide, trim to a point, lengthen and shorten. You can break it or trim it. There's also, what's really nice is they also have these shortcut keys on the keyboard. So you can actually access them without dragging your mouse back and forth on the screen kind of thing, which makes a big difference. I use the shortcuts. So I'll just take you through a file for that. So they've created this file kind of thing. So if I go to my wireframe menu and dynamic trim up here, it brings all those options back. So I can trim 1, 2, 3. And like I say, you can access those off the keyboard if I hit the options on the keyboard. So if I wanted to trim 3, for example, you can come in, click 3 on the keyboard, and you can do and click the 3, and you'll get those. Just so everybody's aware too, you can also drag those as well, and it'll cut that. So you can drag that trim through those. I'll do that again. So you'll be able to drag those and trim those. Oops. Oh, let's do 2 instead. So I wanted to keep these 2. You can drag through there. So I'm just holding the left mouse button, click down, and you can drag through. I'll do that again just so everybody can sort of see that. So I'm doing the 2. If I click on the screen and drag that through, you got to get in there to see it. And trim those off. Whatever side you want to keep, you drag the cursor through, and then that's the side you'd want to keep. You do have all the options for lengthen and shorten. They're all, again, all on one area now, so you don't need to be bothered trying to find different menus on the screen and everything. Everything's culminated into one toolpath area, or sorry, wireframe trim area. So that's pretty much dynamic trim. So I'll just be moving along now. So if I go into chordal deviation, So in Mastercam 2023 and previous, chordal deviation was calculated in, or it's actually the setting for it is actually in the configuration. So when you're trying to do a toolpath in 23 or before, if you're changing your tolerance in your toolpath, you could end up getting stuff like this with facets happening because you're not actually changing the chordal deviation. So chordal deviation is defined as like following that curve in Mastercam. So you can see the facets happening here on this one here, where it's close, it's right on the line there, right on the line there, but in between, that's that tolerance. So in 23 and before, it was in the configuration. So when you calculated the toolpath, even if you made it at 1/10, it still doesn't really matter because you're not changing the configuration. So new in 2024 now, they've changed that chordal deviation to apply inside the toolpath tolerance itself. So when you apply a 1/10 tolerance, now you'll get a lot finer, crisper following of that curve right along. So I'll just call up a file and I can sort of demonstrate that. Chordal deviation. So the example sort of shows I've got two toolpaths calculated in 23. So one toolpath for the tolerance is set at 1 thou, and I believe the other one's set at 1/10. But if we backplot these, and I take a good look at the curves, you'll see exactly what I was showing on the slide. So if I zoom into these areas, you can kind of see where it's hitting the line here and hitting the line there, but the in-between, it's not really doing anything, and that's because of that curve chordal deviation. So even if I change the backplot and I go onto the 1/10 toolpath and I backplot that, you're going to see it's an improvement, but it's still giving you that same type of error that's happening. So now what I did, I copied those two toolpaths down and recalculated them with the same 1 thou tolerance. But if we look at this toolpath now, you can see how closely that's following that line. And it's right there. You can only see some of the yellow coming through in certain areas. And then if I wanted to go finer with it and do a 1/10 on that, I think that's actually set below that. But if I turn this on and I backplot this, you can see just how close it's actually right on that line now. So this would become important if you're doing for surface finishes and stuff like this, like maybe satellite customers and stuff like that. So this makes a difference. And the other thing that's nice about this, as far as I understand it, when you call a legacy toolpath, so if you open up a file from 23 and before, if you were to recalculate the toolpath, because the chordal deviation now that was in the configuration here under tolerances, so the chordal deviation was there, that's a separate chordal deviation now to do with the geometry. In 2023 and before, that was to do with the toolpath. And if you changed it in the configuration in 23, then your toolpath would look very similar to what's on the screen now for 24. But many people didn't know about that. So what they've done now is put it inside the toolpath. So what I'm trying to say is if you call up an older file from 23 and you recalculate it in 24, if you haven't made the changes in the configuration to the chordal deviation, you will see an on-screen difference, and it will be much better to follow that curve now because you're actually using that chordal deviation tolerance at 1/10, which would make a big difference, like I showed you with the facets happening and everything. So that's new for 2024 is the chordal deviation now is calculated inside the toolpath. So for customers with old files, you should be able to call those back in, regen that toolpath. And like I say, if you haven't played around with that chordal deviation in the configuration, it should improve the toolpath on the edges and follow those curves a lot more closely like that. So it's a good improvement for 3D machining basically. So I'm just going to move on to my next thing now.
One quick question on
Yep.
that.
Yep.
Does this increase the file size? And
It would.
Yes, I was going to say I'll
It
let you
would.
answer that, but I believe it does.
You can sort of see that just as an example on the screen here because these are the same toolpaths just calculated with different tolerances, and you can kind of see it's the same step over and everything else. The 1 thou there, and then you can see the difference here. So they're putting in a lot more points by putting the 1/10 tolerance, which again gives you that and follows the curves exactly. So to me, it makes sense that it would absolutely make the toolpath bigger. And you, like I say, you can see the differences in the sizes there. So I'll move along now. So for deburr toolpath now, they've added a few changes. One of the major enhancements that they put in is called avoid contact on tip. So one of the previous deburr toolpaths, if you're using 5-axis normal to contour, you're going to get that ball of the tool right on the tip. And I have a file to sort of show this. But now with 24, they've introduced an option where if you select tip, you can avoid the contact on the tip itself, which makes a difference because basically at the tip, we all know it's cutting basically at 0 and you're pushing the material out of the way. So now we have this option now to avoid the contact on the tip. So if I call up a file for this, we can go through this. And again, I've got a couple toolpaths here. So if we're using 5-axis simultaneously, normal to the contour, we've got this option for tip. And I'll just show you what that looks like. Okay. Now we're recalculating. Okay. So there we go. And this is the kind of the old way, showing it right on the tip. And you can see what's actually happening there. You're basically cutting right on that tip where there's basically nothing happening. You're pushing material out of the way. So if I come into this one here, and I've got the same curves and everything defined, the only difference in the toolpath is I've selected tip and I'm turning on the new option here to avoid that contact on tip. Now, if I do this one and I backplot this, you can clearly see exactly that it's doing exactly what it says. It'll miss that tip of the tool itself and just use the edge. So now you're actually cutting the material instead of pushing it out of the way, kind of thing. And it goes all the way around. So then they took it a little bit further and they've added now with flank and taper. So we all know we can cut with the edge of the tool here. So now with this 2024, they've introduced down this drop down box. And when you do call that up and you use this option to flank or taper, you can set a percentage here. So for 50%, you'd be in the middle of the tool that you're going to be doing that tool path on. So I'll just demonstrate that. So I've got one here now for 50%. So it's approximately 50% from the tip of the tool to the edge here where it stops cutting, and you're in about 50% of the tool. So then if I change this now, if I were to change that to 25, it's going to get closer to the tip that it'll start using. And we can just let that recalculate and you'll see what's going to happen. Now we're much closer to the tip. So you can demand which part of the shaft or the cutting area on the flute you can actually cut with to deburr, which is kind of nice. So, and like I say, you can change that so it's up the shank and closer to the shank of the tool. So if we did like 85%, we can get close to the top. And I did these small examples just to give you so it didn't take long to calculate kind of thing.
Quick question on that was, can you tell it to climb or conventional?
I believe that would be in the way you've selected your chains.
Yep.
So it's in this one here, I've selected the chains in that direction. So you could, I think, it would just be a matter of reversing this chain. Let's just see. Okay, so it's still going climb milling on that. So, not that I'm aware of. I thought changing the chain direction would do that. I'd have to look into that a little bit further and get back to the person about that for that question.
Yeah, can you change it on the tool option? I'm just thinking that.
No.
No, okay. How about if you select, if you do a new one and select in the reverse, is there anything that pops up?
Not that I'm aware of, Lee.
Okay.
I
Yeah.
thought it was just a matter of changing the chain. But I could, like I say, if that person needs to answer, I can look into that a little bit further afterwards, and I can send them an email or something.
Yeah, absolutely. We
that.
can get back to you, Daniel, on that one.
Okay. So I'm just going to go further with the presentation now. So I've showed you the deburr and avoid contact on tip, and there's your flank with the extra box and the 50%. So now I'm going to go into this process hole. This one, it's a very exciting toolpath. It's new for 2024. So this one here, basically you make a library here, and CNC's made a file, and it has all these blocks in it. And each one of the blocks is labeled UNC, whatever you'd like kind of thing. You can do like dowels or whatever. And then in your operations library, you're going to basically make each of the operations part of your process. So once you do a process, so on the screen there, I have a 1/4-inch tap drill. So that would be so it'd be a center drill, chamfer, and then a tap. Now that that's saved in the process hole tool library, we can go back to the file itself. You can pick your holes, apply the library to it, and it'll pop the process hole toolpath on the screen. The nice thing about this is that you can edit these operations and you can explode them. So I'll just go into the sort of examples and I'll show you this kind of thing. So we'll go into the process hole. So I came up with this gear to do this on, and it's just a solid on the screen, but I've got now on this tab process hole up here. So I'm going to select that. And if I select my geometry off the screen, I'm just hitting control and I can click and I grab all those counterboard. That's one thing that this toolpath has to have is you got to define the holes properly to begin with. So now that these holes are all defined properly in Mastercam, we can set our library. So I'm just going to pick that library. And once that library sort of sets in, it'll automatically come up with the process that matches that. If there's multiple processes that match that, like I'll show you that, if I delete these off and say I come to this one, I can get multiple processes to show up. So if I wanted a simple hole, just a center drill and drilled, you could select that process. And when you select the process, it'll automatically update the operations here to sort of show you what's available. So I'm just going to go ahead and I'll process this whole gear. So we'll do those holes first. It's going to select the process that I'm after, and then I can select my incremental. So I'm selecting holes, I'm selecting my library, and then selecting my process. And then if I come to the linking here, I can just select between absolute and incremental. So I'm leaving on incremental and I'll say okay to that. So now you've got the full toolpath there. One of the things that I did in mine, I center drilled and then I've drilled. I just wanted to do this to show you can have it as an option. So many shops, when you're doing stuff like this, a counter bore, so I plunged the tool for the counter bore, but then I've also added a helix operation. So this is good if you were working in a shop and at the time, say the counter bore size wasn't the tool that you had at that time. By building this into this library, you have options now to sort of use whatever tool path you want. So you could go into this process, you could go here and delete off one of these because you can edit these processes too as well. So I'll get into further with that. But I just wanted to say that there's two different processes that I've included in to do the counter bores. And then, like I say, from there, you can sort of decide which one you want and then delete off the other one. And you can use the process as is. So I'm just going to finish the rest of the block now. So these ones here. And again, I'm holding the control as I'm selecting those. And it selects all four. When it's selecting the four, it's because of those holes are all generated in Mastercam or created in Mastercam at the same time. So if I only generated two and then I generated the other two, it would only grab the two. So here I've generated the four at once, so it'll grab all four. And then again, it'll give me the different options that I want in my list. One of the things that matters in this is it's trying to match exact diameters. So this is a good time to point out, if you had 250 drawn on your solid and your process hole tool library, in mine, I've got simple hole 250. I've got a tapped hole drawn at 250 and also a fine thread drawn at 250. So all those processes are going to show up because everything's done at 0.250. So if you were a shop and you were doing a lot of design inside the shop, what you could do is you could set up the quarter 20 to like tap drill size. And then that way, when the process hole picks it up, it'll only give you that option to do the tapping. Right now, you can pick whatever ones you want, but it's up to the programmer to sort of pick which process you're after. So if I want a 1/4 inch fine or coarse thread, I can pick that one, go okay to that and hit incremental, and then I'm good, and it'll drop those ones. So now I've done two of the sections. So if I pick those other holes now, and again, it's only going to give me the operations that pertain to that size of hole that it's looking at, and then incremental, and I can say okay to that. And then again, with the process for the center here, and there's only the one, now I've got 3 different operations. So if I wanted to apply a tapped, I could apply that to it. And again, in my operations library, I've done tap and thread mill just for an example to show you that you can do multiple processes. This would work good, again, like I said before, if you had a shop and at the time the tap wasn't available, then you could use the thread mill option. If the thread mill is not available, then you could use the tap option. So it gives you options by building extra toolpaths inside the process itself. But in this case, I just wanted to add it in to show you that you could do it and also to give you the options. So I'm just going to select this 1/8 tap, and I'm going to go okay to that. And then if I go ahead and I select these holes on the outside, so I'm just going to select the one, because again, when you do the holes, those aren't all done together, so it's only going to select one at a time. So I'm going to go okay to that, and I'll say 1/4 inch 20 tapped. And if I go to my linking, now you're going to see something different because it's not on the top plane anymore, it's on the outside. So all we have to do is set our safety zone. So if I select my solid and I say okay, end to that, if I select cylindrical here and I put it in the Z, now it matches that safety zone, matches the part, and I can say okay to that and okay to that, and it'll apply that clearance around the outside to that part. So now if I take all these operations,
I have a few questions here as well,
Yep.
Dave, but
Yep.
yeah, once you're kind of wrapped up showing this last little bit, then we can address those.
I'm just going to put this on this screen, grab all those. Okay, we're grabbing the first operation, but it's not grabbing the next ones. But this shows you. Let me just grab this. I'm just going to hit regen and display all these again. Then I'll try to verify that. There we go. I'm going to put on my color loop here, so I can slow that down. So again, I've plunged. This is your helix now. So it gives you the 2 options. And then, like I say, you can delete off whatever one you don't want, kind of deal. And then center drill, and the tapping. And then same here. In my process hole library for the tapping, I've done a Z0 on it just to be on the safe side. And then again, you can change that in the toolpath itself. But for the thread milling, you can see how nice it worked there. And it grabbed that all within 1 click. So it's pretty accessible and it's a nice toolpath. So what I'll do is I'm going to go through now. I'm going to show you a different part. It's a multi-axis one. So this one here, I've gone through and we've made all the holes match the process hole library. So all these holes will match now. So if I come in and I select my holes here, again, it'll automatically find the process, and then I can set my incremental and I can go okay to that, and it'll automatically apply that process to those toolpaths now and go through all those. So now if I wanted to do the 5-axis holes, I can do the process hole. And again, because these are created one at a time, you'd need to select one at a time. So I'm going to select these two. And I'll say okay to that. Now it presents me again with the same type of options. So I can select whatever I want out of the list. And then I can go to my linking. And again, I'm going to get the safety zone now because it's not from the top view. So I'm going to get this. I'll grab the solid. I'll apply that rectangular block against it. And I'll say okay to that and okay to that. And then I should get the center drill, the drilling, the chamfering, and your tapping. And again, for the tapping on this, I've left it at 0, just be on the safe side. I figured it'd be easier to do it that way. You can apply it if you want, and it'll have the tap depth in it. It's up to you. One of the things that I've noticed is tapping is a very dodgy situation sometimes, so I made it at 0. So this is pretty much, we can take this now. Let those run. And we'll do our 5-axis hole, center drill, drill, and then you're tapping. And that completes the process. And then again, if we wanted to, we could finish off the rest of the part. And I can pick whatever operations I want and incremental. And then go from there. So I'll go through a few of the options now. So if I do the process hole and I get one up here, now it's giving me the options of which one. So you can see there's quite a few on that one. So I'm going to just pick one. So if I go to the processes here, on these here, this is what shows up, and each one changes to whatever process you pick. So it'll show the operations that are involved. For each one of these, if I do a right mouse button click, I can actually edit that operation before it comes out. But these are all set up to do with the solid itself. So it's using the actual hole itself in the solid to recognize the depths and stuff like this. So you don't really need to do any of this, but if you needed to, you could, and you can do these for any of the toolpaths. And you can go in and change the depths, whatever you'd need kind of thing, or speed and feed or something like that. So another alternative way to do it is that you could do a right mouse button click and you can explode this process. So if you explode the process, it'll drop the automatic, or sorry, not automatic, the toolpaths involved with that process. So it's basically calling those processes from that tool library and bringing them in. So now in each of these, we can do whatever we need to, and you have editing. It's just like a regular toolpath now. The only problem with doing this, not a problem, but you can't put it back into the one toolpath. It explodes it, it's done and over with, and you'd have to redo the toolpath to be able to get that all in one. Because you'll notice these ones come up as one process for all of the toolpaths themselves. So now what I'll do is I'll just take you through the library and sort of show you what you need in the library itself to be able to use these. So if we go into the library, I didn't make the library, the CNC did. So, and all these holes. So I've got blocks. So for the countersink holes. So I come into the countersink. So I've set up all my toolpath groups as corresponding. So, and I try to keep it nice and neat, and then that way everything's labeled kind of thing. And those are the same processes now that apply in that process library these are all the same operations that you'll see show up. So now in each of these, they're connected to the solid itself. And I'll point this out that you have to use holes inside a Mastercam to be able to make this work properly. So in these ones here, they've actually done holes with the solids here, and then off the hole menu here, and you create your hole. And then when you create your hole, now it'll show up properly here to be able to pick this countersink, and it'll determine what it is off of the geometry on the solid itself. So then if I go into these, countersinks, and we go on to the 1/4 inch one here. If I edit this, you can see another new thing for 2024 is this bottom edge treatment. They've got a flip now, so you can do the flip, so you can flip the counter or the countersink to the other side if you wanted to. You can also apply a bottom treatment to it too now. And there's chamfers and fillets available for this. So you'd be able to use a fillet if you wanted to. This isn't anything to do with process holes. It's separate modeling functions that you can do. But I just wanted to show you that you can add those now. So you can do a bottom treatment and you can add that, or a fillet if you wanted to, and it'll add that in. If we turn that over, you can sort of see that fillet happening there. So that's new for 2024 as well. So I'm just going to escape out of that. But if I come back to that solid, you'll notice that these are all the holes in the solid are all countersinks. They're not just a basic hole. So you have to define the hole properly to be able to use it with your process hole library. And then inside the files itself, if we calculate depth from the top of the line and hole and use incremental values, I can set these to basically 0. It'll calculate the depth. Right now I've got it set to overwrite the depth and use the tip. So it's calculated that inside the toolpath itself. But on the drill, you can see here, I'm not going to any depth. It's actually using the solid to see that depth. That's the key when you select the solid on your actual part, is that hole's defined properly, because that depth will fill in with that hole that you have on the screen. And you can set it up using these options, or you could also set it up using the hole segments. So we can define which hole segments we want to do. So with drilling, you'd want to use the tool tip and the drill diameter to be able to drill that hole. So you could define it this way too. So you can define the process itself with either the active segment, or you can do it with the options here kind of thing. But I have the whole process hole library here. So, and this is all available. So I could make this available, and I know there's copies of it on the forum that's available for people. The only dangerous thing about this is that if you steal somebody else's process, if they've made their because some people like to do 1/2 inch tapped holes, for example, at 7/16 drill, which is oversized compared to what your tap drill actually is. Now, if you use that and it was critical that you needed to use that actual tap drill size, you could sort of screw up and do the wrong thing. So you'd have to, so if you're going to take this process and make it your own, you'd have to go through all these toolpaths and make your process to what you need. Do you know what I mean? Because like in mine, for example, on a 3/8 counterbore, I'm making the counterbore itself 5/8. In some shops, that might appear as 3/4. In some other shops, it might appear as 5/50. So that would be a dangerous. So you'd have to go through your whole process, whole library to be able to check everything and make sure the process is correct to what you want. And you can use any of the processes and apply it to those holes like what I was showing. So that's new for 2024. And I think that's pretty much covered the whole process hole toolpath now. The one thing I didn't show is I've got a part here. So if I go here and I've created the same gear, I remove the history from this. So if I come and I check this solid, you can see it's on this, it just says body. It doesn't show any type of history at all. So, and this is the way a lot of people are going to import their parts. It'll come in and it'll show a body and it doesn't recognize the holes. So if I go to the model prep and I find holes, I'm going to find holes off of this because it's the only solid on the screen. It's going to find that solid. Well, I took away the selection there, but find that solid. And this is to create a single operation. So on those counterbore holes, I can create one single operation that'll have all those holes in it. Or if I unselect that, it'll create each operation. This is to do with picking your holes. So if I leave that on a single operation, when I go to pick all those counterbore holes, it'll be picking one and it'll automatically pick the rest of them. So I'm just going to leave that as a single operation, which makes it easier to pick for the toolpath. And I'm going to say okay to that. Okay, let's redo this again. Okay, hang on one sec. Let me just reopen this file. Go to this. Say find holes. Okay, not sure why I'm not selecting holes right now. Let's see this again.
I've got quite a few questions around this process hole, so you.
Okay. Okay.
It's
If
a
you
good
want to
one.
start shooting a question,
There's some interest here for sure, which is great. And I wanted to wait because I knew that you would, ideally address some of these questions as you went through everything.
right?
But let me just go back to the
That's what
beginning.
my
So
problem
as soon as
There
you're
we
done
go.
there.
So my problem there was I had faces selected. So I'm going to just do that again to show everybody. I had
Yep.
faces selected.
As opposed to
I
bodies.
inadvertently hit it, and you needed bodies. So once I did the body, and I'll do that again just so everybody can see that, because I don't want to show any trickery or anything like that. So again, with the solid, I'll show that has, sorry, no history. And we're going to show that has no history, and it's on that body now with no holes. So now we're going to do find holes. I'm going to make sure it's on body, and it's already selected the solid because it's the only one on the screen. If I apply those holes now, it'll grab 41 holes in the body. And again, what it's going to try to do is apply all those processes, or it's going to try to apply the holes found in Mastercam to the solid itself. So now it's found all these simple holes. Now with this, we'd be able to go and we could pick our process hole toolpath and go from here. And I think we'd be able to pick those. It should come up with that. Okay, so it's still not recognizing it. This again, because it should recognize those holes. Okay. Just do that simple 1/8. Okay, I'm not sure why I'm not getting that.
I see two sets of operations in that solid body. That may have something to do with it.
It could be, yeah.
Mm-hmm.
I don't know. Maybe some of the questions.
Yep, for sure. And then you can get back to that afterwards. We can address that after Eric as well. So the first question that we had was, I guess earlier on you were explaining your holes have to be defined properly. So there was just a general question around that. What do you mean by your holes have to be defined properly?
Okay, so in this example here, when I say that, I'm actually using, so if you were designing a part in-house and you're going to put holes in it, you would have to use hole operation here, and you could pick which ones you want to use here. So if I wanted to do a counter bore or a countersink, you could use these to apply to the solid. When you do that, as long as your process hole tool library matches these exact numbers, it'll find that hole.
Yeah. So it's more essentially from an engineering standpoint or a drafting standpoint. You
Correct.
You want to design and draw as your part needs to be machined, essentially.
Exactly. That's why I was sort of saying, if you're designing in-house and building in-house, like a tool and die shop, you could design those holes. Because right now, like I say, if you pick that 1/4 inch hole, it's going to apply many different processes, and you have to select. If you were to design that solid, and from the design itself, it comes out as 234, then you know that that's a tap drill size. And if you set your process hole up, so for this one here, we could set this up, and you change that to 234 hole or 235 and go from there. Now, when you pick that on the solid, it'll find that in the process hole tool library, and you'll be able to pick that operation.
Associated correctly. Yeah. Okay. And the next question then, would this work if I brought in a step file from SolidWorks? Or I guess the same thing, you could say a pair solid from
It should work,
SolidWorks.
but
It'd be similar to the example you were just showing now, where you
exactly
brought in a brick
you'd have to
solid
come
or
to
solid.
yeah. So you'd have to come in, you'd have to find your holes. But again, I'll point out, when you find the holes, it's going to come up here. If this diameter here doesn't match exactly what's on the process hole library, you're not going to see that operation when you go to select the hole through the process hole toolpath. It has to be exact. And one of the things right now. I know they're still working on this, but right now it's down to even the bottom angle has to match for your 118. So if that was 120 on your part and your process hole tool library was at 118, you're not going to see that. You'd have to change it to exactly what the library is. That's why I was saying if it's an in-house where you're doing design and build in the same place, you could work with the designers to sort of let them spit out what you're looking for to do the program. And then that way it'll come out exactly. And you could literally pick those holes and go from there kind of thing.
Yeah,
But to answer the question, yeah, you can use a step file and bring in the holes. Yes.
Okay.
So
Next question. How are the depths calculated for the process holes? Are they associative to the selected surface or contour?
no. So what it's actually looking at the hole itself.
Yep.
So if the like on mine, the block was, I believe it was 2 inches tall that I did the process library on. So when I assigned that, I basically showed it the hole itself in solids and defined the hole. That's the simple hole that came up on the screen. It's looking at the solid. So it's not looking at the depth or anything like that. It's looking at the hole itself, the solid. So when you apply this now to this block, which is only 1 inch thick, like come in here, it'll shorten that toolpath up automatically. And yet my process hole tool library is 2 inches. So it'll automatically find that with that feature because it's looking at the actual feature inside a Mastercam, which is a simple hole. That's why it's important to define the hole properly up front.
Next question. Can you use a contour with chamfer or a deburr within process hole?
Can you use a contour?
Or
No.
a chamfer within
No.
process hole? I'm going to say
No.
probably no, because it's just essentially meant for drilling holes.
Okay, so
Yeah.
just to be clear, we can use this on drill, circle mill, helix bore, chamfer drill, advanced drill, and thread mill. Those are the options that you have. So it's basically all your hole making toolpaths that this can be applied to.
Okay. Yep. And as you mentioned, it is a work in progress, so it will,
Yep.
with feedback, it will definitely be worked on and improved.
Yep.
How do you add a group of toolpaths for a hole to a process hole library? So I think potentially that would be, I guess, can you create your own? And which you can, right? Like this is going to answer other questions that we have. It's like, where do we get these files from? This file, I think, is created. The process hole library, as an example, is created by Mastercam. You alluded to that.
Correct.
Mentioned that already, right?
Correct. Yeah, they created that file, but you could create your own if you wanted to. The important thing is that when you're putting, like, if you create your solid on the screen and you do a hole in it, you're going to use the solids menu here, hole. And if I wanted to do a counter bore hole, I could do that and change your sizes to whatever you want. Once you apply those, make the toolpaths for it, and you've applied it correctly, now that'll be in the process hole. So it'll be available in the library itself. But I'll go over that. I can go back to the library for that. But I did want to show you this one here with no history. I've added the history in now. And I don't know if people were I'm sure people were watching what I did. I changed this bottom angle to 118. Like I pointed out before, that the hole has to match exactly to these parameters for it to work. So when I change that to 118, now all of a sudden when I come here and I come to the process hole there, if I grab those on that dumb solid where we made the holes, so now Mastercam found all the holes. If I go to that process now, it's picking up that 3/8 now because I changed that angle on the bottom. And I know that that's the same thing for the other holes here too. So if it's not finding it, it's to do with that angle. So again, these ones here. So I'm just going to delete those off.
And that's something that I think we've already kind of, as far as feedback, we've already sent that back.
Like you say, it's a work in progress.
A little less stringent, potentially.
So in the library itself, like just for an example, I've got this, let's see, if I call up a countersink. Maybe my quarter countersink. So when I've defined these, that like I said before, these holes have to be defined properly. So this is the solid that's connected to on the screen. So if I go to the solids here and I select that hole itself, you'll see that it's down here. So the hole has to be defined properly, again, with that 118. And now that I've defined my hole, now for the operation itself, I can come in and I can select that hole. The key to it is if I delete that off, if I come in and select this, you're getting a solid face here. That's not going to work with your, because it's not seeing the feature itself. So if I delete that and I double click, I should get that countersink. That's what's needed for the process hole. Because what it's going to do is look at that whole solid hole countersink. And that's how it defines the depth and everything else. It's defined in the actual solid. And then you can say, okay, to that, regen that tool path. And again, you can see the block is much thicker here that I have the 2 inches. So you can see that applied that process correctly to the gear that I did, because it was only an inch and it adjusted the whole thickness. So it's not drilling, 2 inches deep kind of thing.
Yep. Okay, thanks. I think definitely I will say this, there's obviously a lot of questions, there's a lot of interest, but depending on each shop and how you're doing your tool paths now, they may work for some, it may not work for others. But by all means, I think we can get very specific with you. You can contact either your rep or tech support, and they can have a look at a file that you might be interested to look at this in depth a bit more, and sort of handhold through that whole process and do a little bit of Q&A.
Yeah.
Okay. So next question. Just bear with me a second here. When you edit the tool path, it does not change the preset processes, the process parameters.
No,
No.
because what it does when you actually do the process hole tool path, it pulls those from the library and drops a new one, so that basically now you've got this on the screen to do this part. It's not interacting with the library itself, only to pull those operations, and that's it.
And
so it can't really go back and change anything or edit. Yeah, if you needed to edit this, you could go into the parameters here. If I click on the parameters, and I can do a right mouse button clear, click there, edit the parameters I need here. If I save this, or if I just exit out of it, it'll automatically save those options. That's not affecting the library at all. The library will still remain exactly the same.
Okay, perfect. And then again, there's another question: are these files available? Yes, they are. I suggest you just reach out to tech support if you're looking for these files, and again, they'll be able to get that info to you.
Yep.
Okay, next question. Can we create a whole process for SAE or ORB ports that use form tools? So that's probably going to be more of a pro drill thing, but I'll leave that to you, David.
I think you could do it. It would be, because I don't think it's really looking at the tool itself. It's more looking at the tool path. And as far as I know, like I mentioned earlier, you'd be able to use this on any of the hole making tool paths except for FMB drill, the auto drill, and the start hole. Everything else is available. So I don't think it really looks at the tool itself to be able to do it. So you could use any tool you want, I think. So I think that would work as a process. You'd probably be able to come up with a process.
Yeah, and it may depend on how complex the form tools are, but that's something that we can definitely look at offline, James, for you specifically. So the question here is, does it work with 2D? I would say the answer would be no, it needs to work from a solid.
Yeah, no, it's actually the 100%. It's from solids alone.
Solids, correct. Okay. Next question is the example the center drill would be called up 5 times. Can this be grouped? Oh, I guess maybe in one example, the center drill was called up 5 times. Can this be grouped?
Okay, so I know where that question's coming from. So if I do this and I come here and I pick this and I say, okay, and I drop my process, then I pick another one and I'll grab that one, same thing. And I can, so now I get what they're trying to say, because really it's going to center drill now.
Yeah.
It'll finish this. What you could do in this case is once you drop your processes, you could explode the process, explode this process. And then what you can do is grab the center drill from one and drag it into the other one here. And once I do that, now I have the option. I could actually do the point sorting if I wanted to, and go okay to pick a hole, go okay to that, regen that, and it puts all your center drills now into the same toolpath. There is no way to apply that before exploding it. So you'd need to explode it before you'd be able to move those operations or put all the center drills first. Because I know what you're after. You'd want all the center drilling first and then the other processes. So this would be the way that you'd be able to do that, is explode the process and then drag one center drill into the next, basically.
Okay. And it looks like what's potentially the last question, which I think we need to keep moving in the interest of time. If you make changes on a different part to a hole type, does it automatically update within the process hole library?
No, the process hole library is a separate file. So in order to do any type of changes, you'd have to open that file itself and edit the changes, make the changes there.
Yeah.
So you can't using the toolpath itself, all you can do is apply those processes. You can't make any edits to the actual library. You'd have to open the library file to do that.
Yeah. Okay. All right. I believe we've answered all the questions. If we haven't, please reach out to us, and we'll certainly get an answer. So reach out to either your rep or tech support. By all means, work through this with you. It's a big animal. It seems there's a lot of interest. It's a relatively new operation and enhancement. So of course, there'd be some things that maybe you're looking for that aren't quite there yet, but it is a work in progress.
One thing that I point out, you mentioned about wireframe. I just thought of this. So you said about wireframe in the solid. So the process hole
question about 2D. Yeah.
Right. So the process hole library is made up of the solids and everything, and the toolpath itself is for the solids. If you did have that process hole library and you wanted to apply it to 2D, you could do a right mouse button, click import, find that library, and you could pick that process and apply it to your geometry. So you can still use it for importing. So it could still be used for 2D.
Okay. Okay. I think that's it for you, David. That was the last portion, correct?
Yep, correct.
All right. So I think we're going to swap it over to Eric. I did have a quick poll while we're transitioning over to Eric, and I'm going to pop it up on the screen here right now. If anybody feels like answering, basically the question is, are you using Mastercam 2024 already? Yes, no, or I plan to soon.
Cool. So I guess I'll take over now.
Yeah.
So first, thanks, David, for the awesome presentation. That was great.
Yep.
For anybody who doesn't know me, my name's Eric Sears, and I'm a application support specialist. I've been with in-house for about a year, or over a year now. And I do mostly some tech support, training, these days a little bit of contract programming, and a little bit of post editing too. So we're going to be looking at my top features for Mastercam 2024. So these are the enhancements that I'm looking at. It's going to be the machine group setup, the new save load toolpath default, area mill enhancements, dynamic mill enhancements, area roughing enhancements, waterline enhancements, the axis contour enhancements, and the new changes to edit common parameters.
Just quickly,
Yep.
Eric.
Oh, you can't see my screen, can you?
No, not yet.
Okay.
That was because I had the poll done, but
I got you. Okay.
yeah, it's
There you go. Now I can.
out.
Cool. You see my table of contents?
Yes.
Yes.
Perfect.
That was
Awesome.
my
Okay.
that was my fault, Eric. I had that. poll.
No worries. All good.
Just before you jump in, though, I will say I got some responses here. So 30% are already using Mastercam 24, 44% are not, and 26 plan to soon. So that's good.
Awesome.
That's great.
Okay, so the first thing that I want to look at here is the changes to the machine group setup. So there's a pretty big change last year in 2023, and it removed some features in previous versions that some of our users are missing. So they did add them back in 2024, and let's take a look at them. So I got a file I'm going to load up here. So when I go into the machine group setup, again, looks very familiar, same as 2023. Familiar if you were using 2023. So looking at here on the left side of these, this new panel layout, we have all the same tabs that we had before. In 2023, some of these were just placeholders for future functions that they wanted to add, and now in 2024, these are actually working. So the first tab here, the machine tab, there's been no changes here. This is all still the same as 23. So we'll go down to the next tab, and that's going to be the master model tab. So this is what allows you to select your part for simulation, ensuring that you always have the correct model selected. So you can do that either by selecting from a level, you can load the file just from like a file explorer window, or you can select it from the graphics view. This doesn't apply to verify. This is only for actual like mock sim machine simulation. But I'm gonna define my part here. So I just click add from a selection, and then I'm gonna select my part and do end selection. And you'll see here, I get some information regarding the volume and weight and just engineering information. So we'll go down to the next page here, which is the stock setup. So the main features that are missing from 23 that were in previous versions would be the add from two corners. I know that's a big one that a lot of people were missing. Create rectangular stock and create cylindrical stock. So we're going to give those a try. I'm going to go to my other view sheet here where I have some wireframe. So this would be my stock, and I want to use the add from two corners to define that. So I click here, and then I click on two opposing corners, so like the upper left and bottom right, and there I get my stock defined. And then we have some more options here. So I can change the anchor point where I'm anchored to in terms of my stock. So I can change that around. I can change the length, width, and height parameters here if I wanted to modify those. And we also have the option to use push-pull graphical tools to define the stock. So if I just click on one of these faces here, let's say the top face, I get a little arrow here, a little handle that I can click onto, and then I can drag up and down, or I can type in a value. Let's say I want to do 10 millimeters. Oh, I think I have my num lock on. So you can do 10 millimeters and then hit enter, put in like an absolute value, or I can snap that to specific points. So very similar to before. The new features here for this push-pull tool would be now we have the option here to change these values by either incremental or absolute coordinates. And that would be relative to your work coordinate system. And we also have this checkbox here for both directions. So you saw that there. Let me turn it off so you can see. I can either just change this one side, or I can choose both directions and increase it in both directions. The other options here would be create rectangular stock. So I can click on that. And now I just click on my part, do end selection, and it just gives me the minimum volume rectangle around my part. But I'm going to delete that and just go back to my add from corners. So moving on here down to the next tab, we have work holding. And we have this little icon here showing that this tab is disabled. So we can enable it just by clicking on this checkbox right here for the fixtures. And I can define my fixtures very similarly to how I defined my master model. In this case, I have my fixtures already on a level. That's typically what I do in all my files. I tend to put all my fixtures on level 1000. So I just clicked right here to select from a level. I select my level 1000 and I do OK. And then it brings my fixture in. If I was bringing in my fixture from a file, let's say I had like a step file or something, which I had my full assembly of my fixture, I could do it that way as well. And I even have some options here to use align to face and dynamic transform to move my fixture around and get it positioned how I want. So moving on, we'll go down to the Tools tab. There's, again, no changes here. This is the same as it was in 23. And then the last tab would be Simulation. So the Simulation tab consolidates all of the simulation data into one location. And what we want to do here is I'm going to select the machine that I want to simulate my toolpath with. And we also have this new section here, stock override. So in previous versions of Mastercam, to do a stock override for, let's say, verify, you would come over here to this simulator options button, and then you would choose stock model, and then select which stock model you want to use when you launch verify. So that's been moved now to the machine group setup page. I think this makes more sense. It's kind of all in a familiar location now. It's really relative to simulation in general. So if you click on this simulator options button, it will bring you to this location now. So what I want to do is I want to enable my stock override, and I'm going to use a stock model. I only have one here, the roughed stock. And now that I have all my simulation options set up, we can launch simulator. So I'll click OK. So this is the stock model that I should be launching with. And I just want to simulate this one helix bore toolpath. So I'm going to go to the machine tab and launch simulate. And oh, I might not have selected my fixture. Let me just go back and double check that. It should be selected. Oh yeah, I must have accidentally unchecked the fixtures box. Let's just launch that once more. There we go. So this is kind of nice now that you have your fixtures for verify and for MockSim kind of in the same location. Same thing with a stock model override. It's in the same location for verify and MockSim. The only thing that isn't shared between those two is the actual part model or the master model. So verify will still just use whatever is visible on screen at the time you launch verify as the part model. So that's it for the machine group setup changes.
I have 2 questions here.
Yep.
So under stock setup, is create lines and arcs still available as in Mastercam 2023? I find that very handy when aligning fixturing to initial stock. And
So do you mean like show wireframe entities? Is
I
that here? Let me.
I believe so. Under stock setup, is create lines in arcs still available? So in this, that's I guess specifically in the stock setup portion.
Oh, I see what you're saying. Create lines and arcs. You mean the create additional geometry. So that would be under, I think if that's only available if you're using from a bounding box. So if I go back here, let me just delete my stock. And if I choose the add from a bounding box option, so this is what you had in 23. And again, in here, you can also create rectangular and cylindrical stock in a more complex way than you would with the new options. So like, let's say I did the rectangular and then I go down. Yes, you still have that option to create lines and arcs and solids and whatever other additional geometry. So yeah, that's still there.
Okay. And it was a two-parter. And then it says, what about making the red wireframe stock geometry pickable?
So that is still not pickable. I find the best way to get around that is to actually use this create geometry, which I'm sure is what you're doing since you had it in your question.
Yeah.
Yeah, that's typically my workflow is I'll create a solid from this bounding box and I'll just put it on another level to use when selecting, say, my depth for like facing my initial stock or something like that.
Okay, thank you.
So no changes there.
And then one more question. Is simulator the same as MockSim?
Yes, so simulate is the same as MockSim. The one that I see a lot of people mix up is verify and simulator are two different things.
Yeah, and I guess we should say like it's the same interface, but there's definitely a difference between simulating and the machine sim. Like from if you have a complex 5-axis machine, as an example, that would be something that needs to be created and developed for you.
Yes, absolutely.
Whereas there are generic machines available to do that from a machine sim perspective. But if you have something that's not generic, then it's certainly machine sim is a purchasable item because it's completely custom to your specific machine.
Yeah. Okay, so moving along here. The next feature that I want to look at is the new ability to save and load toolpath defaults. So in previous versions, you were able to save like a single default for your toolpath parameters. And let's just open up the file so we can see exactly what I'm talking about here. So looking at this feature right here, let's say I wanted to finish the walls of this hole. So maybe there's two different kind of strategies that I use very frequently with contour. Sometimes I want to do like a depth cut approach, and then sometimes I want to do ramping. And I have very specific parameters that I would like for each of those two strategies. So what you can do now is sort of set up some presets or like profiles that you can easily switch between on the fly. So I just selected my geometry there. I'm gonna just go select my depth plane, do it at the bottom, and then do like top of stock. I'll pick a tool and I'm going to enable depth cuts. And let's generate the toolpath. So here's my toolpath. I'm doing depth cuts, looks good. I'm happy with this. So let's say I want to save these parameters. What I'm going to do is in my toolpath, I go to the Save Toolpath Parameters to a File button right here. And that's going to open up this new interface. It used to be when you would click that Save button, that just saves the default when you open up that toolpath, and you just have that one profile. So now you have the option to choose multiple ones. So first thing we look at here at the top, these two checkboxes, we have default or custom. So default is basically what you had before. It's just going to save that profile across the board. Whenever you open this toolpath, those are the parameters you're going to get. But I want to do a custom one, so I'm going to choose custom. And then down here, I'm going to click this plus to add a new preset. And I'm going to name it depth cuts. And I'll click OK. So that saves all my parameters to that preset file. And now I have this new drop down here where I can see my different profiles. So toolpath defaults and contour, these are really the same thing. They're both the default when you open the toolpath, but now I have this new profile that I created. So I can select that, it's gonna load those parameters, but it's just the same still. So now let's say I wanna use a different strategy for this. I said I wanna do ramping. So I'll go back into my cut parameters and I'm gonna choose ramping and do OK. Okay, yep, my toolpath looks good. That's what I expect. So I'll save this preset now. I'm going to do the same thing. Click on Save Toolpath. And I'm going to create a new preset. Name it Ramp. Click OK. And now I have my depth cuts option and my ramp option. So I can see this being probably my most used new feature from 2024. So I can see if I click here, do depth cuts and apply. There's my depth cut toolpath. And then choose again and go to ramp. And I get my ramp toolpath. So I can see this saving me tons of time. I probably wouldn't even use the like import export toolpath feature for nearly as many things anymore now that I have it in this simple drop-down menu. So that's it for this enhancement. You'll look at the next one here. So that's the area mill enhancements. So if you're a user of area mill, you know that it's great for finishing like open pockets and faces and closed pockets because it allows you to select geometry very similarly to how dynamic mill works. You have an avoidance region and a machining region and air regions and all that flexibility. But the downside to it is that it typically has a lot of retracts. So the enhancement now is that if you're working on an open pocket or a face, then you can use the zigzag strategy and have a high-speed linking move. So let's take a look at how that works. So I have this area mill toolpath that I created here, using it to machine all the flat areas. So you can see down here, I'm doing this pocket, and then I'm doing this face up here. I have tons and tons of retract moves. So if I go into the parameters and I go to the cut parameters page, you see here I have these two options. So closed contour cutting direction, climb. So that's going to be for any closed pockets. So like this main pocket right here is closed on all sides. There's nowhere for the tool to enter in the air unless this hole was already pre-drilled. So that would be a closed contour. And then we have open contour direction. So that would be any face like this or open pocket like these milled out sections right here. So I can choose here, instead of one way, if I change this to zigzag, and we'll hit apply. And we can see a pretty drastic difference here. So a lot less linking moves. Of course, now we are doing climb and conventional milling, which when you're facing isn't like a huge deal. But especially in this case, we're only taking off a little bit of material. Depending on the material that you're using, it might be useful to you or not. But you can see now we have these very fast, high-speed linking moves, no more retracts. I think in this case, I had looked it up and it was about a 75% reduction in rapid time, the rapid length and time. So that's going to be machine dependent and part dependent. But this is a really nice feature. I see myself using this a lot because that's been one of the big reasons why I would not use area mill, was just because I know that it typically had a lot of retracts. So that's it for area mill. We'll look at the next one here. So this is dynamic mill maximize engagement. So maximize engagement is going to allow you to reach your programmed step over faster. So let's take a look at this. So what I find myself doing a lot is if I'm roughing out some part and I'm choosing between either dynamic OptiRough or area roughing, I'm kind of leaning towards one or the other depending on what type of tooling I'm planning on using. So if I'm planning on using a long end mill where I want to go like full axial, then typically I'm going to use dynamic OptiRough. But maybe if I'm using like a high feed mill, then I might prefer to use area roughing simply because there's no like lead into the cut. It goes to my program step over right away. The downside with area roughing is that you have a lot more retracts. You don't have those micro lift retracts like you get with dynamic mill or with OptiRough. So now the enhancement to dynamic mill, really any dynamic milling toolpath, so that's going to be 2D, even Face has a dynamic milling option, and OptiRough, they're all going to benefit from this. So let's look at this first toolpath here. If I go to the cut parameters page, here is the checkbox right here, maximize engagement. So right now it's off. And I'm just going to backplot this toolpath and we'll see what happens as the tool enters the cut. So it's leading in, very little engagement, and it's building up, getting larger. And then once it gets to about this far into the cut, now it's reached the actual program step over. So in this case, we're only, a program step over is maybe 25%. If I was using like a high feed milling cutter and I'm doing like very shallow passes, but a large step over, my step over might be 70 or 80%. So reaching that program step over would be that much longer into the cut. So that's probably the reason why I wouldn't use a dynamic milling toolpath for that type of tool. But now I have this operation here, which is an exact copy of the other one, only with maximize engagement enabled. And let's backplot this and see what happens. So when we're entering the cut, boom, we're right at our programmed engagement. So for those like high feed milling tools, you're going to reach that program step over like instantly. So now you have the benefit of reaching your step over right away, and you get the retract-free high-speed linking moves of dynamic milling. So it's really a win-win with dynamic mill now for that sort of operation. And I wouldn't really be choosing between one or the other. The answer is pretty clear to me which one's better. So that's it for the dynamic mill enhancement.
Quick question there.
Yep.
And there's a couple others, but we can backtrack because I'm
Okay.
going through the list to make sure I didn't miss any. So
Yep.
specifically to that one, if this is going to save time, if this is going to be saving time, should this I guess, should it always be turned on anyway? I guess it really is dependent on the material and the type of part and the tooling that you're using. But
Exactly.
yeah,
Yeah. So it's I wouldn't have it on all the time. Like so for cases where I'm using like a really long end mill and I want to do like a full axial cut with a very small step over, depending on how small that step over is, um, maybe if it's not that small, maybe if it's like 25%, I don't want to be leading into that instantly in every case, right? I might want to gradually lead into that.
yeah,
Um,
yeah. Okay.
so depending on the type of work you do, maybe you do have it on all the time, but I think for me, I would have it off by default and then only turn it on in those cases where I want to use it.
Yeah. And then is there a way to make, I'm not sure if this is completely related to what you just showed, but is there a way to make OptiRough not hug all avoidance geometries?
So yeah, that's a good question. So if we take a look at OptiRough here, I'm going to launch OptiRough toolpath, and you have the machining and avoidance geometries here. And I found this out a little while ago. It's interesting. So if you click on the help button here, I even working for Mastercam, I use this button all the time because it's very useful for getting information on the more obscure like toolpath parameters where maybe like it's not really clear just by the name and the checkbox what it means. So if we hit
Yeah,
that,
and actually on that note, we have mentioned this before in the past. What's nice about that question mark is it follows you around. So as an example, if you go ahead and click on planes in that window that you're in,
exactly.
and then hit question mark, it's going to take you straight to the planes page. And we have touched on this in the past, but I think that's a great reminder. And I agree with you, that help is fantastic. And it really does, it can sometimes give you an answer to a question that's then you don't have to necessarily wait for support as well. Or, of course, by all means, call support, but
Yeah.
that help menu really is good. And like I said, it does follow you around whatever operation you're in, whatever page you're in. And, if it's specific to planes, then away you go.
Yeah, exactly. So what I'll do here so I'm looking at the model geometry, and if I click this drop down for parameters, you can read here about the information about avoidance geometry. So the interesting part here is dynamic OptiRough, area roughing, and horizontal area use avoidance geometry as machining geometry. So what that means is there really isn't much of a distinction between these two pages in terms of those three toolpaths. Now there is a solution to your problem, and I'd have to really look at your part to tell you for sure, but what I would tell you is make sure you're using stock models, and if you're using rest machining, then that's probably going to avoid the issue that you're running into. But I would send that file into tech support, and I could take a look at it and tell you what's wrong with it. But
yeah, that's great. Yeah, Tyler.
yeah, I'm really going to have to look at that part to know.
Yeah,
for
send
sure.
that into support at inhousesolutions.com, and they can work through that with you. Okay.
Okay, so that's it for the dynamic mill enhancements. So next I want to look at area roughing critical depths. So critical depths is a feature that you might be familiar with if you use Waterline. And let's open up the file so we can take a look at what that is. So I have this part here with a whole bunch of different pockets. They're all at different depths. And I'm using the 3D area roughing toolpath to rough out this material. So I'm going to throw on a section view just so we can see a little bit better what's going on here. We can see the kind of depth cuts that we're taking. And let's just go into the toolpath parameters for a second. On the cut parameters page, I have my step down defined as 200 thou. So what Mastercam is really doing when we calculate this toolpath is it looks at, okay, this is all the geometry that I selected. At its very highest point, it is at whatever, this depth here. The first cutting pass that I'm going to make is going to be 200 thou down from there, no matter what. It doesn't matter about anything else, what other geometry is below it. It's going to go 200 thou down. And then from there, it's going to go another 200 thou down, and so on. So if your flats here, my floors of all my different pockets and features, if they don't happen to lie on one of those like 200 thou down passes, I'm not going to end up cutting this floor to my programmed stock to leave. Like in my toolpath here, I have it set to 0, and you can see clearly that I am not leaving 0 stock to leave on this floor down here. I'm like probably 200 thou above it. So what we can do now, the new feature is if I go into cut parameters, I have this option here for critical depths. So this is just a checkbox. We can turn it on. It's very similar to what you would have seen in Waterline. And we have this drop down here to either include flats. So that's just going to look at all the geometry that I selected, find all the flats, and it's going to create an additional cutting pass at that depth. So let's just do calculate and see what we get. And you can see that now I'm machining that floor right to 0 as I programmed. And all the flats are getting hit. So you can see the pocket down there, this little open pocket, they're all getting hit. So it's a small feature, but I think it's a nice thing to have. But that's it for the area roughing toolpath. Or actually, we can look at one other thing with that, and that is the manual option. So in critical depths, we have the option for include flats. We can also do include manual. And with this, we can specify specific depths that we want to hit. So if I go to select here, let's say I don't care about any of the other bases here. All I care about is hitting this open pocket right here. So I'm just going to select a point. Say I can snap to this arc center. So you have to select a point. It has to be either like an end point of an edge or a midpoint or something like that. You can't select a face itself, but I'm going to select there, and I'll do OK and recalculate my toolpath. So now you can see it added an extra cutting pass right at that depth. You can see that line right there. So moving forward, the next thing we want to look at is the enhancements to the waterline toolpath. So we have a few different enhancements here. I think it's better to just show you. So here I have a part that would not really be ideal for using the waterline toolpath, really. And the reason for that is because we have a mix of both steep and shallow geometry. So on these edges right here, the wall is very steep. And on this section here, it's a very shallow angle. So typically waterline is best suited for only steep geometry, but there is other ways that we can sort of get around that to use it for this type of geometry as well. So our starting stock here, We're machining this from like round bar, and then we're gonna do an OptiRough on this side, and this is our resultant stock model. And then we're gonna do another OptiRough, basically the same thing on the other side. And then this is our resultant stock model. So now we want to create a waterline toolpath here. So we're using pretty much default settings for waterline, except we are also using rest passes. So in my stock page, my toolpath, I have enabled trim to stock, and I selected my stock model, this stock model right here. So the toolpath is only going to create cutting passes where it sees stock. If there is no stock there, it's going to trim away that part of the toolpath. In this case, there's stock everywhere, so it's just going to cut all over, and that's what we see here. However, in previous versions, the toolpath is only looking at the stock model from what it can see from the top view. So like looking straight down. It isn't aware of any undercuts to the stock. So it's just going to keep machining down until my whatever depth I programmed it to go to. So the new enhancement here, if I go back into my parameters, is this checkbox for detect stock breakthrough. And if you use this in OptiRough, you'll know that it's the exact same checkbox, pretty much does the same thing. I have this toolpath already generated because it will take a little bit to generate. So I'm going to select that here. And we can see now that we're only cutting in the areas where it needs to. So it's trimming away all the extra passes that would have just been cutting in the air. So the next enhancement here is for these sections right here where we have these shallow sections. So if you use Waterline a lot, you'll know that you can use the Add Cuts feature to add some cutting passes here. Let's look at what that looks like. I go into my parameters and go to my cut parameters. So we have our step down here, and that is just straight Z step downs. It doesn't care if it's steep or shallow, we're gonna do the same step down no matter what. Well, we can add this checkbox right here, add cuts. And what that will do is it will allow us to use a profile step over. So that's a 3D step over across the surface. And I've already created a toolpath. Again, I don't want to be calculating this now. So let's just look at my new toolpath. So I did add cuts. I made my maximum profile step over the same as my step down. And I just have a 0.5 millimeter minimum step down. So what you can see now, if I switch between the old and the new, is that we have a lot of extra cuts here to kind of even out that surface. Now, the downside to this is that those extra cuts go all around the part. So they're even hitting these steeper surfaces here where we wouldn't need the extra cuts. If I switch between, you can see that a little bit better. So that's no enhancement. That's how it was before. But the enhancement now is the ability to do partial cuts. So if I go back into my parameters here, you see we have this checkbox here for allow partial cuts. So this next toolpath here has that enabled. Now you can see that we have some lead, these are actually lead outs, but we have lead in and lead outs. So we're only cutting in the areas that we absolutely need to maintain that 3D step over. And if you look over here in the steeper sections, you can see we don't have any extra cuts like we did before. So you can see all that extra cutting time that we're saving now by using partial cuts. And we're still getting that same step over that we wanted. So this might not be the most ideal toolpath to use for a part like this, but this part will absolutely show the power that this new enhancement gives you. So that's it for the waterline enhancements.
There was a quick question, if you could just quickly verify that part.
Yep. So, and actually another thing that I can show here. So if I go to my simulator options here, I don't have a stock override on right now. And I'm just going to close out of that. So a new feature with 2024 is if I include, like I select this stock model when I launch verify. So I have my stock model and my toolpath selected and I launch verify. It's actually going to launch verify with that stock model. So I don't need to go and set it as an override every time. This is very nice when you're working on big files and you don't want to be constantly changing between stock models. You can just quickly select them and let it rip. I'm just going to skip through this because it'll take a while. Looks like there's some collisions there with the holder that we might want to look at. And obviously our finish is
That's the
a little
power of
rough.
verify.
That's, yeah, exactly. That's what you want to catch right there.
Yep. Yeah. Okay. I think that was it. I think they just wanted like a visualization on it in verify.
Yeah, obviously it's a rough step over because I chose a rough step over just to make it easier to see the lines.
Yeah. Thanks.
Okay. So the next feature that we want to look at here is the B-axis contour enhancements. So there's been three big changes to B-axis contour. They are number one, the ability to adjust the stock to cut. This is a feature that's in many other turning toolpaths, but it's new to B-axis contour. There's the ability to designate a usable portion of the insert. And there's the ability to edit automatically created tool axis vectors. So let's take a look at that. So I have this this part here, and I'm using B-axis contour to finish this shoulder and OD. Let's just backplot this and see what we're working with initially. So this was just using, I believe, automatic tool axis control. So just let the software do whatever it thinks is right. And we can see here at the beginning, the way we're entering the cut, we're kind of not entering the stock how we would want it. And maybe the angle is not too great either. And then we go into this wall. And then our lead out as well. I would want to extend this edge just so that we go just in like negative Z off the end. So let's go into this toolpath. I'm going to open up the parameters here. And the first thing that I want to look at here is adjusting the stock. So this is going to be, if I go down to this stock tab, we have this option to adjust stock. And we can see here a visual representation of the difference between the in-process stock model and the contour that we selected to machine this. And so if I zoom in close here on the beginning, I have this little green ball that I can click on, and I can drag it around to adjust what stock do I want to remove. And I also have these little white dots that might be not so easy to see that I can snap to. So if I snap to this one, it's going to lead into the cut in only Z. And then if I snap to this one, we can see it just kind of extends the contour until it intersects the stock. So for me, I like this option. So I'm just going to click there to accept that. And then I'm going to do the same thing on the back side. Click on this little red ball, and I'm going to drag it so that I extend in Z off the back edge. So that looks better to me. And now I can press enter to confirm my results. And the next thing that I want to do here is I want to modify the portion of the insert that I'm using to do my cutting. So if I look at my tool axis page here, my basic motion control, my tool axis control is set to automatic. So just let the software do whatever it thinks will work. So when I'm using this option, I have the option to redefine the maximum insert depth. I can choose this manual and then click this button right here. And now I get a nice visual representation of the tool holder and insert boundaries. And I can see here, all this dotted line section is where I'm going to be doing my cutting. Any portion of the insert that's dotted here, that's fair use to use. So what I can do is I can actually just click on these dots and I can drag them around to only use the portion of the insert that I would like. So I'm going to choose like something like that. And then I'll drag this green one down, maybe do something like that. So I only want to use this part of the insert. And now I'll press enter to confirm my results. And I'll click OK and allow the toolpath to generate. So this one does tend to take a little bit longer to generate. I don't think it's too long. There we go. So now we'll backplot. And now I can see where I'm leading into my cut. And my tool axis control looks a lot nicer here as well. And I have a nice lead out on the back edge. So I'm happy with that. And the next thing that I want to look at here is machining this inside bore. So this obviously produces some unique challenges. Finding a tool that's going to be able to reach all the way along this contour without using like a B-axis contour is impossible. So this toolpath, again, is using automatic tool axis control. And we can take a look at what the toolpath was able to come up with. So I'm going to backplot this. So here's my boring bar. The lead-in looks nice. I think I might just change my options here to make this go a little bit faster. Once I get down to this section, I sort of run into some issues with the holder running into the stock. The angle between the insert and the contour is not great. There's not really much clearance there. And going around the corner, that's not bad. But now once I get to about this section, my holder's kind of, it's not quite running into my part, but it's getting very close. And then the rest of the toolpath here is not so bad. I'm pretty happy with that. And we lead out and exit. So what we can do, if I go into the parameters of this toolpath, and I'm going to go to my basic motion control page. So we have this set in automatic, and we have this new option here that's new to 2024, which is modified. Before there was only automatic or manual. Well, now we can choose modified and click here to edit the vectors. And so what this is doing is these are the vectors that were created automatically. And now we have the ability to just let it create an automatic one. And then depending on what we get, we can adjust from there to get more of what we want. So you can see these green arrows. I can click on them just to edit the vector. You can see here, it's showing my tool as red when either the holder would impact like the in-process stock model, or if it is an angle that is not reachable. You can see it here, it won't let me go past minus 25 degrees because the machine's not capable of that. So I can just manually modify, okay, I want to lead in like this angle, and then I'll just click to confirm that. And I can also add more tool axis vectors very easily. So if I just double click on this contour, say right here, I get a new tool axis vector, and I can modify that one. Maybe I want to do something like that. And if you look closely here, on this yellow contour, we actually see some red portions. So these red portions are showing areas where the toolpath is either the holder is gouging the part or it's just not reachable. So this is a nice indication of telling you, okay, this is like a problem area you need to take a second look at. So I can modify that. This color is not going to update until I regenerate the toolpath. And actually this toolpath takes a little bit of time to calculate. So I've calculated it ahead of time, and we'll just look at that separately. So I'm just going to exit out of here, and we can see the file that I pre-generated. So I have a nice lead into the cut here. I think let me put this on interpolate just so it goes a little bit faster. We can see that I'm keeping a nice angle between the material and the insert cutting edge. Go around this turn. Clearances look nice, not gouging anywhere. And then the tool straightens out for the end to lead out. And then my retract. So that's it for the enhancements for B-axis contour. And then the last enhancement that I want to take a look at here is the edit common parameters. So in 2024, this is a very small change, but I see it as being very impactful for the programming time of certain parts. This is actually an issue I ran into recently, where I had made an entire program for a customer, and then once the program was done, they decided that they wanted to change the orientation of how they were going to hold the part. So it meant that we have to change the WCS plane. And this was a 5-axis part, so I was using tool planes and construction planes. And I wanted to be able to change just the work coordinate system without affecting any of the tool planes or construction planes. So let's take a look at that. So here I have this part, and really the only two tool paths I want to look at here are these two drilling operations. So you can see my first one, I'm drilling from the top plane, and then my second one, I'm drilling on this angled face right here. And if you look closely here, you can see that my first operation is using WCS op1, and my second operation is using WCS top. Now they both have different tool planes and construction planes, so I don't want to change those. I only want to change the WCS plane. So what I can do is I'm going to control select the two operations, so I have them both selected. I'll right click and go to edit selected operations and edit common parameters. And then I'm going to check the box for planes. And I can just come here to work coordinate system and come down and change them to use both use op1, and I'll click OK. And I've just changed the work coordinate system of both operations without changing the tool plane and construction planes. So before you would have had to change all three. So for a 5-axis program, that would mean that you have to go into every single tool path individually and go change all of the tool planes and construction planes manually. But now you can see my work coordinate system is changed for both of them. And everything looks good. So that's it for all the new features that I wanted to show off for 2024. Here's my contact information if you want to reach out with any questions or anything. Lee, I'm assuming there's maybe a few questions still we want to look at, or?
Yeah, there's one that we can double back on for you specifically, and it was when you were saving your operations to that library.
Yep.
And I mean, I believe I know the answer to the question, but I think it'd be good for you just to bring that back up. And so the question was, are we able to edit those custom tool paths and overwrite them? And I mean, obviously, it would just be a matter of going back into what you've saved, library-wise, and bringing that back up and editing. But I'll leave that to you.
Yeah. So as far as I know, I don't know if there's a way to like directly edit them. So if I go here to like click on save and I look at them, you only have the option to rename or delete them. So what you could do, say I wanted to edit my ramp one, I would just load it,
rename
and
it.
then go and like delete it, and then just save it again.
Yeah, or rename, right? You could use the same one and then save it as something different.
Exactly. Yeah. And to delete them, you just right click and choose delete, and then it's gone from that list.
Yeah, or go back in, edit, and save as one different. Can you do that?
Yeah, exactly. Yeah, I could just it'd be the same as just saving it before.
Yeah. Okay, perfect. And then there was this one's going back to David, and this was
Yes, sir.
When you were showing off the trimming of the entities.
Yes.
The question is, can you change the settings so that the sides you want to trim will be removed? And my guess is that's going to be trim divide. But I guess specifically if you were selecting, you always have to select what you want to remain.
Exactly.
But if you, I don't know if either you or Eric could just quickly show something to that effect. But I think probably in specific to that question would be the trim divide, because then you just click on what you want removed.
Yes, exactly. Yeah, that would be the click. Yeah, exactly. Divide would work like that.
Okay.
You'd click on
that's
what
what
you'd want removed. Yep.
You just want to fire up your screen, quickly just show that.
Yeah, you have the file with all the geometry, so you can just grab the presentation.
Sec.
Just because, sometimes I know that trim divide's been around for a little while now, but sometimes the new enhancements can get missed by just because it just gets buried in with everything else. I think the trim divide is a pretty neat option.
Okay, so you see this? Do you see the
yes,
trimming?
we can see everything now. Yeah.
Okay, so if you use that divide function, it'll remove the stuff that you don't want.
Yeah. And I
think that answers that.
Yeah. My mind, that's the way to go about it for that specific question.
Yep.
Okay. Okay, there's a few more questions here now.
I think that can we rotate the cube and create a new plane? I think he's talking about like create a plane from G view. I remember.
Oh yeah, you can rotate this cube, and then if you wanted it on that exact view, you could come into planes and selection option here from G view, and it'll grab that plane, and then you've set that plane now. And if I go away from that, And then I can come back to that same plane. Sorry. And I can come back to that same view. So yeah, absolutely. You can create a plane from the view on the G view. If you come to planes and then right off from G view.
Okay, thank you. Then there's the question about any Swiss turn enhancements.
No, not for like Swiss machines
Yeah, like
specifically.
Swiss machines, or Swiss. I guess you could say Swiss turn is effectively mill turn now, unless you're using mill and lathe with a post processor that will operate a Swiss machine.
Yeah, nothing new for Swiss specifically.
Yeah. And then there is a question in simulation options. How can we load new machines into it? Where do we get the files for each machine? So this is machine sim specific. There are default generic machines, I will say. I don't know if either of you two could quickly show what's available for default, but anything outside of default and generic is an option that needs to be purchased, as it's very custom and very specific to your machine and the machine models.
So machine sim, you could select these ones here. That's what comes with it.
I guess
the standard
there
machines.
is a question: is there any Haas machines in that default library?
Not that I'm aware of. No.
No, it would just be a generic 3-axis if you have that, or a generic
Correct.
horizontal.
Yeah, it would come up as a generic 3-axis. Yep.
Yeah.
So that answers that question. Thank you. Okay, very good. Okay, thank you, everybody. We appreciate you taking the time to join us here. Of course, if you have any questions on anything, please reach out to us.